Alright, so in this case we're looking for an isoelectronic series that arises from fluorine, nitrogen, magnesium, and carbon. And after we do that, we're going to put them first in order by increasing nuclear charge, but then we're going to put them in order by increasing size. So the first thing we need to remember is sort of what an isoelectronic series is, and that is a series where the iso, same electron configuration. So the thing that's going to differ here is there are different elements, clearly, so their atomic number, their number of protons will change, but the overall number of electrons and their configurations will be the same. So let's take a look at the periodic table and find these and set this up. Alright, so I'm just going to highlight the elements that we're dealing with here when we take a look at it. The first one we're looking for is fluorine, so again up to the right here, nitrogen, and magnesium, and also carbon. Alright, so for an isoelectronic series, we're trying to figure out where all of these are going to want to go. Well, remember nonmetals, things over here on the upper right, they tend to form negative ions. The reason for that has to do with the fact that their effective nuclear charge is pretty high. They want to fill that shell, but they have a lot of protons, and to add an extra electron, yes, it will take some energy to do so, but not nearly as much as adding one on the left. So they're going to tend to form negative ions. Fluorine, therefore, will go towards neon. Nitrogen would add 1, 2, 3 and go to neon. Carbon, 1, 2, 3, 4 to go to the same electron configuration as neon. So these would all become 2s2, 2p6. So helium, 2s2, 2p6, do the noble gas shorthand. Magnesium, on the other hand, okay, we're not going to add 6 to get to a full principal shell of 3. Instead, what we do is take away 2 electrons, goes 1 gets us from 3s2 to 3s1, take off 1 more, and we're going to be back here at neon, okay, which is a full 2s2, 2p6, but we have nothing in the 3s now. Okay, so that's going to be the isoelectronic series. So now we can start to figure out their size. Alright, so the first thing I'm going to do here is write out what we just found out from the table, which is the charges. So fluorine will form the F- ion, fluoride ion. The nitrogen ion will be the nitride, N3-. Magnesium will be Mg2+. And the carbide ion would be the C4-. Now the first thing it states is to actually put them in order of nuclear charge increasing, so we're simply going to look at the atomic number on the periodic table and go based on that. So carbon is the first one, so the carbide ion C4-, which has an atomic number of 6, so 6 protons, and the next one will therefore be nitrogen with atomic number 7. And following that, we will have the fluoride ion, and behind that will simply be the Mg2+, which has far more protons with 12 than the others. So now the second part of this question says arrange them by size. Okay, so we need to go into order of increasing size. Well, in this case, if they all are isoelectronic, the shielding part of things does not matter at all, and it simply comes down to protons. So if we take a look at this, it's in order right now by increasing nuclear charge. So the one with the highest nuclear charge, same number of electrons, is going to pull them tighter, and therefore it will be smaller. Okay, so remember, cations like magnesium, always smaller than anions. So we're simply going to go in order of decreasing nuclear charge. And that will be in order of size from smallest to largest. So magnesium ion is the smallest, fluoride ion is next, then comes the nitride, and finally the carbide ion, which would be the largest.